Today's lesson is going to be lesson 4.1, Areas of Parallelograms from chapter 4. I'm going to go to this website given here. You may also go ahead and play around on the same website about parallelograms. A parallelogram is a flat shape polygon with the sides that are parallel and equal in length. If you notice on this, the angle A and this angle A, they are opposite and equal, whereas these two angles, angle B, are opposite to each other and they are the same measure. The same way, the opposite sides are parallel and equal in measure. Let's go ahead and take a look at a small animation. If you notice, and I'm going to hold the vertex, one of the vertices, and then move this around, you will notice that the angles will, as I move them, the opposite angles are the same and the sides, opposite sides, are also the same measure. See what happens when I move it. Do you see that? Okay. There comes a point where all angles are the same. You are familiar with this polygon. You're familiar with this polygon where the opposite sides are parallel and equal, and these all the angles are 90 degrees. We call this a rectangle, remember? So a parallelogram is nothing but a rectangle that is sort of squashed or moved, for a lack of a better word, let's call it that way. So now it's easy for you to remember that we all know area of a rectangle is length times width, or base times height. And same way, area of a parallelogram is also given by the same formula, base times height. Parallelogram is also given by base times height, where B is the base and H is the height. Okay, let's go ahead and do some problems. Now, all we are doing in this is to substitute for the base and height that are given in the formula and doing the computation. So the area of the parallelogram is given as base times height. The base in this case is 20 times the height given here is the line that is going from the vertex to the base or the opposite side, and it always has to make that 90 degrees. Remember, that's your height. So in this case it is 25. Go ahead and do the math. 20 times 25 is 500. Do not forget the units. In this case it is meter squared. In this problem, the area of this parallelogram is again equal to base times height. The base in this case is 7. Now the height, they have given it outside here. Again, it's a straight line that goes from one vertex to the base and has to make a 90-degree angle, and that is 17. So it's 7 times 18, which is 126 inch square. Let's look at the last example. If you look in this, you will notice there are 3 different measures given. There's a 23.5, there's a 12 yards, and there's a 15 yards. Let's go ahead and take a look. This is also base times height. The area of the formula, or the formula for the area, never changes. Now the base we know is easy to identify, 23.5. What do I multiply it with? Do I multiply it with the 15 or the 12? Now remember it this way. Height is from the vertex straight down, or you can also remember it as, if you're standing to take your height, you never stand at a slant like this. You always stand up nice and tall. So 23.5 times 12, and your answer for this, if you go ahead and multiply, is 282. Again, my units are square yards, or yard to the power of 2. Few more examples. In this case, the parallelogram is on a grid, and let's count out the grids. Base times height. How many squares are covered in the base, there is 1 square times how many squares make the height, and I'm going to extend my line so that it comes and hits the base at a right angle. That makes my right angle, and I went up to 1 square, 2 square, so my height is 2. My answer is 2. In this case, they did not give me a unit, so I'm just going to write it as a square unit or unit square. Let's look at the next example. The height, again, base times height. The height in this case from here is 1, 2, 3, 4. So the height is 4. Let's take a look at the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Base is 12. 12 times 4 is 48 unit squared. Let's take a last look. Look at the last part of this lesson. Okay, now this is one of the key parts that you have to remember. This is where the application part comes from, where you might have a window where you want to make it a parallelogram, or the window or the door, whatever it is, or the tiles on your bathroom walls, and then you want to leave a little piece in the middle to insert something else. So in this case, they want you to find the area of this shaded region. So if you take a look, the middle part is a rectangle. We all know how to find the area of a rectangle. So let's go ahead. And area of the rectangle, in this case, is base times height. We all know that already. So it's 2 times 1, which is 2, in this case inch square. And my area of the parallelogram, and we are talking the entire parallelogram here, is again base times height, which is in this case 9 times 4, which is 36 inch square. Now, how do I find the shaded region? Area of shaded region is equal to area of parallelogram, take away the area of the rectangle. And in this case, it is 36, take away 2, which is 34 inch squared. Let's do one more example of the same kind. In this case, again, the area of the rectangle is given by the formula base times height. My base of the rectangle is 6. The height of the rectangle is 3. 6 times 3 is 18. Unit is millimeter square. The area of the parallelogram, in this case, is, again, I'm going to write the formula base times height, and the base for the parallelogram is 15, and the height of the parallelogram is 8. So 15 times 8, 120 millimeter square. Do not forget the units. Let's go ahead and figure out the area of the shaded region. So area of shaded region, just like before, is the area of the parallelogram. Take away the area of the rectangle, which is 120. Take away the 18, and we end up with 102 millimeter square. All right, I want you to go ahead and finish the rest of the problems given on the worksheet, and I will see you in next class.